Hi, this screencast is on density and volume. So we're going to start by taking a look at derived SI units. This is going to be where you combine SI base units to form derived units. So for example, area, the unit is meters squared. We get it by taking length times width. Volume, we talk about the unit being meters cubed because we take length times width times height. So in this screencast particular, we're going to be talking about density. And density is kilograms per meters cubed because we take mass divided by volume. So here in this table you can see some other derived units: molar mass, molar volume, and energy. But again, today we're going to focus on density. So volume is one of our metric base units with liters, and it's the amount of space that's occupied by an object. So length times width times height, how much space it takes up. The derived SI unit is cubic meters, but we often use cubic centimeters. Okay, so the liter is a non-SI unit for volume. 1 liter equals 1,000 centimeters cubed, or 1 milliliter equals 1 centimeter cubed. So this particular conversion factor, a conversion factor is where we have two equivalent measurements. You're going to want to memorize that because that's how we go from using liters to meters in our metric system. So density is the ratio of mass to volume, or mass divided by volume. So our equation you see here is mass divided by volume. That's how we solve for density. The derived SI unit is kilograms per cubic meter, but we also use grams per centimeter cubed or grams per milliliter. And density is a characteristic physical property of a substance. It does not matter what the size of the substance is, the density remains the same. So if you have a sample of gold, it will have the same density if it's a small sample of gold or if it's a large sample of gold. It doesn't make any difference because that substance is gold, the density will always be the same. Density can be used as one property to help identify a substance. So here in this chart you can see the density for various materials: platinum, lead, steel, titanium, aluminum, etc. You should know that the density of water is 1 gram per centimeter cubed. And this is important because if a substance has a greater density than 1, it will sink in water. And if a substance has a density that is less than 1, then it will float on water. So we can look at density of substances and we can kind of determine, does it float, does it sink, based on what material it's in. So let's take a look at how we solve density problems. Here's a sample problem. A sample of aluminum metal has a mass of 8.4 grams. The volume of the sample is 3.1 centimeters cubed. Calculate the density of aluminum. We want to first look at our given and unknown. So in this problem, we are given a mass of 8.4 grams and a volume of 3.1 centimeters cubed, and we're looking for density. So what we're going to do is we are going to plug these values into our density equation. Remember that density is mass divided by volume. So I'm going to take 8.4 grams divided by 3.1 centimeters cubed, and that gives me 2.7 grams per centimeters cubed. If you need to, please pause the video at this point to write down the sample problem in your notes. Once you finish copying down the problem, go on to the next sample problem. Our second sample problem is, what is the volume when the density is 11.35 grams per milliliter and the mass is 18.43 grams? Now, recalling that our equation for density is mass divided by volume, I'm going to start plugging the values that I was given into the equation. I was given a density of 11.35 grams per milliliter and a mass of 18.43 grams. So that means my equation now looks like this. 11.35 grams per milliliter is equal to 18.43 grams divided by volume. I want to solve for volume, and I need to get it out of the bottom of my fraction here. So to do that, I'm going to multiply both sides of my equation by volume. So that gives me 11.35 grams per milliliter times volume equals 18.43 grams. Again, keeping in mind that I'm trying to solve for volume, to get volume by itself, now I need to divide both sides of my equation by 11.35 grams per milliliter. And when I do that, I get an answer of 1.624 milliliters. Please pause the video and copy down this sample problem in your notes. If you have any questions, please make sure you ask Mrs. Benke before you leave class.